Have you ever stopped to think about the quiet magic that makes our digital world go round? Today, we're going to unpack the science behind making enormous files unbelievably small. Okay, so let's start with a puzzle you run into every single day, probably without even realizing it. How can one single program, like Zip, compress any file you throw at it? I mean, how does it handle a photo, a text document, and a spreadsheet? They're completely different, right? Well, the answer lies in this really fascinating field called universal data compression. And that word universal is the key. It's all about designing these clever strategies that can shrink data even when they have absolutely no idea what kind of data they're looking at. So, how does this actually work in practice? Okay, let's dive into the most common and honestly the most intuitive strategy out there. At its core, the most famous method, which is called Lempel-Ziv, or just LZ, is kind of like a super smart proofreader. Imagine you're trying to shorten a really long book. The LZ algorithm has this simple but incredibly powerful trick. So what's really interesting here is how it works. It creates what's called a sliding window to look at the data that just went by. It then finds the longest phrase that's already appeared, and instead of writing that whole phrase out again, it just replaces it with a tiny little pointer, a little note that says, hey, just go back X characters and copy Y characters. It's basically a giant, super efficient find and replace. And this simple idea, it's so unbelievably powerful. The LZ77 algorithm is so effective, it's considered pretty much optimal for compressing individual chunks of data. It's the absolute backbone of so many compression tools we use every day. All right, let's move on, because this all builds to a much deeper, much more profound question. This is where we shift from the practical into the philosophical side of information itself. If we can always search for patterns, is there a limit? Is there a point where something is just so random it can't be compressed anymore? The answer lies in this incredibly powerful concept. It defines the absolute rock-bottom limit of compression as simply the shortest possible description of an object. Now, this idea is called Kolmogorov complexity, and it's a bit of a mind-bender. It basically says that the true size of any piece of data is the length of the shortest possible computer program that could spit that data out. It is the ultimate compression limit. And this is a brilliant example of how a purely theoretical idea has some really powerful practical applications. This theory inspires what's called the minimum description length principle, or MDL. It's a tool used in statistics and machine learning to find the simplest, best explanation for a bunch of data. But, the world of universal compression isn't just one or two big ideas. It's really a whole toolkit of specialized strategies. For instance, the early pioneers approached this problem from completely different angles. You had Claude Shannon's approach, which relied on knowing the statistical probabilities of the data. But then you have Fittingoff's minimax approach, which is a strategy that's totally independent of all that. So the crucial point here is that this alternate approach had its own unique advantages. Fittingoff's method was simpler and more efficient for small chunks of data, precisely because it didn't need to know anything about the source to begin with. Today, the field includes this huge variety of methods, each one tailored for specific kinds of data and challenges. You've got context tree weighting, perfect for tree-like data. Compressed sensing, which can rebuild images from just a few measurements. Wavelet methods that adapt to the geometry inside an image. And adaptive schemes that just change their strategy as they go. So, what's the big takeaway from all of this? Why does it all matter? It really comes down to this. Universal data compression is, at its heart, about finding and exploiting structure. And it does this even when you have no clue what that structure is going to look like beforehand. It's a universal hunt for patterns, from repeated text to geometric shapes in an image. And that's why it matters. Without these brilliant strategies, our digital lives would be pretty much impossible. They'd be slow, expensive, just a total mess. This is the science that makes streaming, sharing, and storing all this information possible. And that leaves us with one final, pretty wild thought to ponder. If every piece of information really does have an ultimate shortest description, is the universe itself compressible? Think about it.